This project is an automatic vehicle access system with fast, accurate, and secure monitoring of vehicles that exit and enter the premise or territory, where it consists of graphic user interface, vehicle user database along with the prototype. This project also using UHF RFID reader and passive tag. It operates on frequency of 400 MHz to 950 MHz, and the passive tag was attached to the various condition and size of car. The promise statement of the project is there is no continuous vehicle monitoring and ignore the safety measure to identify the identity of every vehicle owner. Furthermore, vehicle that enter the premise only be checked but not be recorded into record book or system consistently. An unauthorized vehicle may be entered the area without alerting the assigned security officer and can exit the premise undetected. The objective of the project is to build a new database and graphic user interface for the registered vehicle. Second, to develop a hardware prototype of UHF RFID vehicle access system associated with Arduino Mega 2560 microcontroller. Third, to investigate the suitable configuration of hardware prototype in order to maximize the system capability. For scope of the project, the system operates on frequency in the UHF domain ranging from 400 MHz to 950 MHz and perform at the distance up until 7 meters. Next, the system will be developed on the Microsoft Visual Studio platform with PHP MyAdmin associated with MySQL connector for database management system. Thus, the field test is located at the main entrance of UTHM where the authorized vehicle is enter and exit the premise, and the experiment is utilized 6 cars during the field test. For the methodology, as you can see, this figure shows the flow of the system and how it works. UHF RFID tag is an input of the system and UHF RFID reader will read the data from the detected tag. The data is then proceeded to Arduino Mega 2560 microcontroller to trigger the servo motor. At the same time, the data will be stored in the database. MySQL database is connected with PHP MyAdmin to manage the created database. The MySQL database and PHP MyAdmin is connected by using MySQL connector. Moreover, XAMPP control panel is used to keep the memory of the data from PHP MyAdmin localhost. As a result, graphic user interface will display the data of the authorized vehicle to enter the premise. This is all the software that I have utilized in order to develop the system, such as Arduino IDE, Microsoft Visual Studio, XAMPP control panel, MySQL connector, PHP MyAdmin, and lastly, Microsoft Excel. For the graphic user interface of this system, this is the first menu, which is connection menu. The second one is the user data menu, where this menu will display the data of the vehicle that passed through the entrance. Next, this is the registration menu, where the data of the user will be registered. To make it work, first run the XAMPP control panel, then fill in the user data and the data will automatically be saved to database of the PHP MyAdmin. And lastly, this is the report menu, where the history log of the vehicle in and out is being recorded. The data is then exported and saved in the Excel as a daily record. This is the prototype of the system that consists of UHF RFID reader, microcontroller, and circuit with barrier gate. Next, this is the setup before the field test is conducted. First, this experiment is to observe the performance of the UHF reader during day and night time. The detection is only limited to 7 meters distance between the static tag attached. This UHF RFID reader detection is not affected by the brightness of the surrounding environment during the static condition of the tag, 0-degree angle of the reader, and 0 meter difference of height between the vehicle and UHF RFID reader during this testing. This is the experiment to measure the readability of the passive UHF tag with different density of windshed. The experiment is implemented on 6 different vehicles with different density of the tinted windshield. As a constant variable, 10 times of passing trial with 20 km per hour of average vehicle speed has been set. Hence, the vehicle is randomly picked to satisfy the actual situation when the system is implemented. As a result, the decreasing performance of the readability of the tag at the tinted windshield as the tinted contain high metal material. Thus, the tag is most readable at the range of 0% until 20% of tinted windshield without any detection failure. To observe the maximum detection distance between the reader and the distance of the tag in static condition at 60-degree angle and 2 meter height of the reader, these results show that the reading distance when the tag is static condition and moving condition is identical under the same environment. Next is to measure the performance of the system with different speed of vehicle. From the graph, it obviously shows that the higher repetition is occur as the car speed is slower. The ideal speed of the passing vehicle is between 20 km per hour to 50 km per hour. Thus, the passing vehicle that less than 20 km per hour is considerable. To summarize the result, the system is able to work in the maximum capability when the UHF reader is in 64 degrees, mounting pole of the UHF reader is 2 meter, the maximum detection is 7 meter, the system is able to detect the vehicle in the speed of up until 50 km per hour, and lastly, the ideal tinted windshield of the vehicle is 20%. As a conclusion, the automatic vehicle access system using ultra-high frequency RFID is wholly functional, as the interface is successfully developed to register user data and record the registered data into the database. The detected passive tag attached on the car can be read and transmitted to graphic user interface and trigger the barrier gate to open. And from the experiment, I am able to investigate the maximum capability of the system by performing the field test. This is the connection menu where we need to choose the baud rate of the UHF RFID reader and connect it. This is the registration menu where the admin can register the vehicle, and the data grid will show the list of the registered data in the database. This is the user data menu. The graphic user interface is ready to receive the data from the UHF RFID reader. Then it will display the data that is detected by the UHF RFID reader from the tag that have passing the entrance. The data is recorded in the report menu and ready to be exported.
Bila kita dewasa, sekali lagi maklumat ni datang ketika kita sudah mampu berfikir dengan baik, ketika kita sudah menjalani kehidupan yang